Hello, everyone. My name is Frank Vidiello, and today I'm going to be talking about carbon sequestration. Before I can get started, I just want to give a brief overview of what it is I'm going to be covering. The first thing I'm going to be talking about is what exactly is carbon sequestration and give a brief background on it. The next is going to be the capture of the carbon, then about the geologic sequestration of said carbon, and lastly about the impacts it may have on our future. Before I can really get started into what carbon sequestration is, it would be beneficial to give a brief overview of the impacts humans have had on the carbon cycle since the rise of industry. The cumulative release of anthropogenic carbon dioxide has been estimated to be anywhere between 2,930 and 3,500 gigatons of CO2 from 1870, which is the rise of industry, to when this data was collected, which was 2018. According to the Intergovernmental Panel on Climate Change, today's emission rates are around 67 gigatons per year. However, around half of these emissions are naturally removed by the ocean and terrestrial biosphere. This being said, the Paris Agreement still recommends limiting average atmospheric warming to less than 2 degrees Celsius to avoid the worst potential impacts of global warming. So overall, the main goal of carbon sequestration is to take a portion of this anthropogenic carbon and store it back into the earth. At its most basic form, carbon sequestration is a natural or artificial process by which carbon dioxide is removed from the atmosphere and held in solid or liquid form. For geologists, it's the injection of this liquid CO2, which is called supercritical CO2, which is held at 304 degrees Kelvin at a pressure of 7.4 megapascals, of whose density is around 600 kilograms per meter cubed, into geologic structures in Earth's subsurface. The understanding of Earth's complex climate systems and understanding the anthropogenic effects we have on them is a fundamental key for carbon sequestration. Sequestration is key for mitigating atmospheric pollution and slowing or potentially even reversing some of the anthropogenic causes to global warming. There's an amplitude of ways in which carbon can be captured, but right now there are two being focused on for large scale use. The most abundant method used today is directly at the site of the power plant. Here is a model of what this looks like today. Here in the smokestack, a filter is placed to absorb CO2 emissions. Once the filter is saturated, it gets moved here where they place it in a solution to extract CO2 and other gases. From there, it is taken to a facility to transform it into its supercritical form. From there, it's placed back into the well to enhance oil recovery from the well, from a well that may not have been producible. Here is a model of Exxon's. This project is currently being funded and is underway. What it is attempting to do is to store the captured carbon deep underground where it could be safely stored. Another way is through a method called direct air carbon capture. As of now, this is currently being researched and funded, but the idea is very similar to the smokestacks. There's a filter, it's just in sort of a fan. It will collect and compress carbon for the purpose of later storage. This is an artist's rendition of what direct air capture could potentially look like. It's, however, not actually what it looks like today. The main idea of geologic sequestration is to trap carbon dioxide into the subsurface for hundreds to thousands of years in safe conditions. Depleted oil and gas reservoirs, deep unminable coal seams, deep ocean sediments, and deep saline aquifers are the main storage candidates. However, among them, deep saline aquifers seem to be the most focused on due to its enormous capacity. Supercritical CO2 may be stored in these types of formations. Ideally, the reservoirs are thick and located below 1 kilometer of depth with high porosity and permeability to ensure high storage capacity. Suitable reservoir rocks consist of sandstone, limestone, and basalt. Suitable cap rock is made up of shale, anhydrite, or any low permeability carbonate rocks like this dolostone, which actually happens to look a lot like a cap. Now we're on to the effects. CO2 injection can create pressure perturbations, which may lead to leakages in aquifers or to the surface. This accumulation can cause harm to the biosphere. Brine or CO2 leakage can also halt subsurface operations. Effective monitoring methods are necessary moving forward. Each geologic site is very unique. Cap rock formations that contain swellable clay minerals are particularly concerning. CO2 interactions may lead to structural effects such as shrinkage, desiccation, and plastic response. However, according to the IPCC, it is essential to permanently sequester about 10 billion tons of CO2 per year by mid-century, and roughly 2 times that per year by the year 2100. In order to stop or reverse the worst effects of global warming, anywhere from 100 to 1,000 total gigatons must be displaced from our atmosphere. According to Exxon, they capture around 7 million tons of CO2 per year and account for around 40% of the total carbon captured. If we take these estimates for face value, you could easily estimate that roughly 17.5 million tons of carbon is sequestered per year. Now, I know that may seem like a lot, but it's a far cry from our goal. Take into consideration the fun fact that 17.5 million seconds is about 28.9 weeks or 6.6 months, but 10 billion seconds is 317 years. With that kind of scale, you could more easily see the difference between these two large numbers. The challenge that was called for may seem daunting, but there is some hope. Right now, carbon sequestration is our current best hope for long-term carbon storage. As of now, it's financially booming industry getting funded by many groups and the government. The US Department of Energy has announced an $11.5 million in federal funding. Exxon and Global Thermostat signed a joint initiative to try to create technology advance to source capture, and Microsoft pledged to invest over $1 billion in the capture of carbon. This was actually back in 2020, and since then they've published what they've been doing in the last 2 years, and in the last 2 years they've been responsible for over 2.9 million metric tons of carbon dioxide removal. I hope you guys enjoyed my presentation, and that is the end.